All right, so we're picking up where we left off on Friday. If I were doing my notes here, I would say consumers get their energy by eating once living resources. Consumers get their energy by eating once living resources. Do we have to have energy for an ecosystem to work? Absolutely we do. Consumers are also called heterotrophs. Heterotrophs means that they feed off different things. So if we were thinking about an ecological pyramid, my producers would be at the very bottom, and it would be the biggest section. My consumers would be going up by tertiary levels all the way up the ecological pyramid until the very tip top. Usually stops at tertiary consumer, simply because if you keep passing 10% of that energy on, it gets to be such a small amount that it's not worth passing on past that point. Right, so producers actually get their energy from the sun, but not all producers. Just almost all producers get their energy from the sun. There are a few exceptions to this rule, and one of those exceptions is a process called chemosynthesis. Chemo, what science class does that sound like? Chemistry, right? Synthesis, from photosynthesis. What do you think synthesis means? What does photosynthesis do? It changes. So does it make something? Yes, it does, right? It makes glucose. So chemosynthesis is where you are making your energy from chemicals rather than making energy from the sun. So some prokaryotes use chemicals as an energy source. There are organisms at the very bottom of the ocean that actually use heat as their energy source. Heat from thermal vents in the ocean floor. They can use that heat to generate their own food resources. So most things photosynthesize, some things chemosynthesize. And I promise you that's a word that's going to be important. Not all consumers are alike. First-year biology, or biology in general, has more new vocabulary than first-year Spanish. You're learning basically a new language. So consumers can be broken down into lots of other groups or names. Herbivore is a type of consumer that only eats what? Plants, right? Carnivores, what do they eat? Meat, other animals. Omnivores, what do they eat? Everything, plants and animals. Detrivores, this may be the only one that's new to you. You may have never heard the term detrivores. Detrivores eat dead organic matter.
So that's what a buzzard is?
Yeah, a vulture or a buzzard is a detrivore. Any scavenger is a detrivore. And then you have your decomposers, like this mushroom here. Decomposers are detrivores, so it's a subdivision of detrivores, and then they break down organic matter into simpler components. So these are the things you would use in a garden to take organic matter and turn it into compost. You would want some decomposer detrivores. I have those paper towels at the back of the room, Amaya, in the dispenser. I'm sorry, I don't have any tissue. So now we've got to talk about some of the relationships that happen inside of a food chain. Raise your hand for me, showing me if you're still writing here. All right, I'll wait for you. If you haven't finished this page, get it from a neighbor. We're going to look at predator-prey. Predators are things that kill other things to eat. So predators kill to eat. Prey are the things that are being killed in order to be food. So looking at a snake and a mouse, the snake would be the predator, and the mouse would be the prey. Here, I can draw, this is a type of relationship. I can draw a model to help me remember the relationship between predator-prey. Predators, one is happy, so I'm going to have a smiley face. So there's your predator. He's helped by this relationship. And then over here, my prey, he's dead. So one is happy, one is dead. That's a predator-prey relationship. So food chains and food webs excuse me, are simply a model of the flow of energy in an ecosystem. This is a new heading on your C notes. And if I were taking my notes, I would just say food chains and food webs are a model. That's all I'd say. And just like we passed our rocks the other day in the flow of energy rock game, what is always moving through an ecosystem? Energy, absolutely. So in a food chain, there are things called trophic levels. You've heard me talk about them several times now. A trophic level are nourishment levels in a food chain. Primary consumers eat producers. Secondary consumers eat herbivores. Tertiary consumers eat secondary consumers. So primary, secondary, or tertiary is just their name depends on where they're located in that food chain. So this would be my primary consumer, my secondary consumer, and my tertiary consumer. That is actually really simple. That's all that means. Primary is first, secondary is second, tertiary is third. What has to come before my primary consumer? Yes, a producer has to be there. Now, sometimes you have an animal like a human who we could just go and eat a salad, right? So in that food chain, we'd be a primary consumer. Or we can go out and eat a steak. And in that food chain, we could be the, what would that be, secondary? Because the cow ate the grass, so we ate the cow, so that'd be secondary. What if we ate shark for dinner? We can, absolutely. So what if we did? Where would we fall then on that food pyramid? At the top, which we call what? Tertiary. Yes, babe, go ahead. Allergies are going around bad, I think everybody. You know, that's why I was out sick the other week, was my allergies. All right, so this that we're talking about here, it really only relates to a food chain. A food chain is one simple strand. But we can put many chains together and make what's called a web. This image here is an example of a food web. So, a new heading on your notes, food web is complex network of feeding relationships. New heading, food web is a complex network of feeding relationships. Do you guys only eat one type of food?
No.
We eat lots of different types of food, right? Every different type of food that we eat is a different chain. So a food web can have multiple feeding relationships inside of an ecosystem. For example, this shark here, he's got 2 lines going to him, which means in this web, energy has flown to him through 2 different organisms. So in this web, he has eaten 2 different things. Now, that number could go up significantly. So, organisms may have multiple feeding relationships. A food web is a lot more complicated than a food chain. In a food web, you get a bigger picture of the ecosystem. You get to see how things interact. And sometimes you discover that those interactions, that the animals somehow, some way do it on purpose, and that somehow that interaction benefits one or the other. And I'm talking more than just a predator-prey relationship. They're actually called symbiotic relationships, and we're going to get into those either into the class today or for sure tomorrow. So we've taken a few slides of notes. Here's what I want you to do. I want you to look back with a highlighter, skim over what we did on Friday and what we've done today. As you skim, I'm going to ask you a few questions. So get out a highlighter. If you don't have a highlighter, it can just be a colored marker. There's some on your tables. I want you to start with your notes from Friday. At this point, if you would like to chunk those notes and mark your text, you circle important words, underline key ideas. This would be a good time to do that. And I want you to do that all the way up to the notes that we've taken today. Yes. So we are marking our text and chunking our text. Point of this is that 10-24-7 rule, right? You review it after 10 minutes. You're going to be more likely to remember it. You go back and review it again after 24 hours. You're more likely to remember it. We repeat this again after 7 days, and guess what? You remember it. What grades do you think you'll make on that quiz? A. That is the goal, right? So take about 2 minutes. Go ahead and skim your notes. I'm looking for marking the text. I'm looking for circles. I'm looking for highlighting. I'm looking for boxes drawn around like information. What have I given you that make it easy to chunk? Well, the highlighter, obviously. The headings, right? I told you when to write a new heading. Guess what? Each new heading is one chunk. You awake, Berrigan? Don't go to sleep on me. What do we call things that only get their energy from the sun? There's two names. Producers or? Starts with an A. Autotroph. Okay? So if producers are called autotrophs, what is the other name for consumers? Heterotrophs, absolutely. All right, you should be wrapping up your marking and chunking. New heading. This one is the 10% rule. What did we do in class that modeled this? The triangle thing, yeah. We drew a model. What game did we play? Played the Oh Dear game. What other game? The rock game, right? How many rocks did you have to have before you could pass one? Had to have 10. And then you kept 90%, right? And you passed 10% to the next trophic level. How many rocks when we were done did the producers have? A lot. And what happened when we went up each level? What happened to the number of rocks? Fewer and fewer, right? Guys, that is the 10% rule. So in my C notes, I would have this as my left-hand column heading. And I would say 10% of energy is lost each trophic level. It's lost to the environment as heat. So here, if I were drawing an energy pyramid, this is not going to be the best drawing. I'm drawing with my finger. And I were looking specifically at the amount of available energy. Here I would have 100. Sorry for my writing. What's 10% of 100? I heard it. Say it louder. 10. What's 10% of 10? 1. What's 10% of 1? Not 0.1, it's 0.1. All right, so the producers would have 100%. They can only pass 10% of that on. They can only pass 10% of that on. They can only pass 10% of that on. That is the 10% rule. Now, if I went up one more level, if I had a fourth consumer, then it would be 0.01. My dot's in the wrong place. It should be down here. Give you a second to get that in your notes before we move on. We've talked a lot. We've talked pretty much in depth that energy has to go through an ecosystem for it to work. What happens if there's a break in that energy? What happens to us if there are no more producers? What happened? Everything would die, right? What happens if all of the primary consumers are gone? Everything above that would die, right? Just like energy cycles through an ecosystem, so does matter. So this again is a new heading. Matter cycles in ecosystem. So just like energy is flowing through organisms, through environments, so is matter. Things like water, or carbon, or nitrogen. All of these elements cycle through. And if there's a break in that cycle, either these elements can build up in places or they can be completely missing in places. So the first cycle we're going to look at, and you don't have to memorize this cycle. I just want to kind of give you an idea of how it cycles. The first one is water. So water, that's all I'd write, is that the water cycle. Just know that that's one way that matter cycles. Here in this picture, you can see that water in the ocean evaporates, it condensates and forms clouds, which then precipitates out into lakes, which then can spill over back into the ocean. So you see how that's just one cycle, right? It's just this cycle that keeps feeding back into itself. Everybody understand that? You've been talking about the water cycle probably since, this 4th or 5th grade, all right? So just like water cycles, so do elements. Whoops, I went too far. Elements essential to life also cycle through. So I just put element cycle. A biogeochemical cycle is the movement of a chemical through an ecosystem. One in particular is the oxygen cycle, which we're going to look at today, but we're not going to go into detail because we have a whole unit later this year that is just photosynthesis and respiration. We will look specifically at the oxygen cycle then. Oxygen cycles indirectly. Like I said, you don't have to memorize this. We're going to spend several weeks on this later. Basically, trees output or plants output oxygen. We breathe it in. We output CO2. The trees breathe in the CO2 and it cycles through. Another one that cycles through is carbon. Carbon can go, so just list it as one of the things that cycles. It moves carbon from the atmosphere through the food web and back to the atmosphere. Carbon is emitted during the burning of fossil fuels, and it can be stored for long periods in areas called carbon sinks. Yet again, you don't have to memorize that cycle. You just have to be aware that that element is flowing through an ecosystem. This one, nitrogen. This one's a little bit more important for the things that we're going to study this year. So in your notes, you need to get down the nitrogen cycle is one way that matter is cycled through an ecosystem. What's important about this one is that it happens mostly underground. Some bacteria convert gaseous nitrogen into ammonia through nitrogen fixation. Some nitrogen-fixing bacteria live on the roots of plants. Some nitrogen fixation can actually occur during a thunderstorm. Lightning is so hot that it can fix atmospheric nitrogen and turn it into a form that can come back into the ecosystem. So for the nitrogen system, for the nitrogen cycle, it's most important to remember that this happens underground. So you've been working pretty hard, so I'm going to give you like a 30-second break. When you're done with these notes, stand up, touch a college logo somewhere in the room, and come back to your chair. Get the wiggles out, wake up a little. Stand up, find a college logo, and then get back to your chair. Very, very smart, Cameron. All right, back to our seats in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Oh my goodness, you scared. I thought you had fallen. All right. There's one more cycle that we're going to look at called the phosphorus cycle. It's also underground. It happens because of the weathering of rocks. We're not going to go into a whole lot of detail about it. Just know that phosphorus is another element that can cycle through ecosystems. So you should have a list in your notes. You should have water. What else should you have?
Oxygen.
Oxygen. What else?
Element.
Elements. Which elements?
Carbon.
Biogeochemical cycles, right? So which elements do those cycles? That would have been me, Jason, right here. So we have carbon, nitrogen, phosphorus. What else? Oxygen. Is that it?
Carbon.
Okay. Natural and human activities can disrupt biogeochemical cycles. So you need to know human activities can disrupt biogeochemical cycles. Also things like volcanoes, forest fires, landslides, earthquakes. Those things have an impact on an ecosystem. If an ecosystem burns down, well, then we have to go through the steps of succession. Succession is something you should have learned in the 7th grade. It's simply how plants return to an area after fire or drought or some sort of trauma, okay? So are trees going to be the first thing that return? Are you going to burn a field, come outside the next day, and there'll be some trees?
No.
Why? It's grass, right? After the grass starts to grow, what do you slowly begin to get?
Flowers.
Flowers. What next?
Trees.
What comes before trees?
Plants.
Plants, but
Animals.
what type? Like little bitty plants or like
Big.
bushes? That's what I was looking for, like shrubs, all right? Then trees. And then you slowly start to get into those really hardwood trees after that. So there's a process that has to happen. There's no like miraculous tomorrow 12-foot pecan tree in your backyard. Like, it takes time. So, some things that people do that hurt an ecosystem include farming. If they don't farm responsibly, they can hurt the land. And also burning fossil fuels. Using too much gasoline in your car. All of those things can hurt the environment. So now, guys, we're getting so close to being done. New heading, pyramid model. Pyramid model in your C notes. We've already seen this a couple of times. We've actually drawn it, I think, twice now. But we're going to look at it exclusively now and break down it into all of its parts. We've got 12 more minutes. Y'all hang tight. Hold on with me. A pyramid, an energy pyramid, shows the distribution of energy Energy pyramid shows the distribution of energy among trophic levels. Energy pyramids compare energy used by producers and other organisms. As we've said, what percent of the energy is passed? What percent? 10. So what if 10% is passed, how much do they keep? 90, all right? So from this slide, all you need to get, energy pyramid, distribution of energy among trophic levels, 10% passed. Energy pyramids aren't the only types of pyramids that you can have. You can have something called a biomass pyramid. A biomass pyramid is simply what is the mass of all the producers in an area. No, you're fine. Versus what is the mass of your primary consumers. What trends do you see? What is happening? What's happening to the mass?
It's getting, I can't see.
Get bigger.
Is it getting bigger? What are those squares doing?
Smaller.
It's getting smaller. Think about what you know about an ecosystem. Why would that happen? Why would the number and the mass of individuals get smaller as you go up the pyramid?
The higher you go, the more.
Because of the energy. Okay? So there's less energy available the higher up you go. Which means, think about this. Is there more grass on planet Earth, or is there more people on planet Earth? There's more grass, right? Because there are more organisms that eat the grass. Then there are less organisms that eat those organisms. Then there are less organisms that eat those organisms. It's a rolling effect, right?
Yes.
So you have to start big and go small. There are a few exceptions to that rule. There are a few times where you start small and go big. And we'll talk about one of those exceptions tomorrow. There's also something called a pyramid of numbers. That just tells you how many animals are present at each level. So the biomass is looking at the mass of them. This is looking at the total number. Only 4 slides left. Y'all hang in. A vast number of producers are required to support even a few top-level consumers. So you need a lot of producers to support even 1 or 2 tertiary consumers. Because remember, the amount of energy available decreases every level you increase. Does anybody have any question about that?
No, ma'am.
Pretty clear, right? Easy breezy. Here's what I want. Sitting at your table or across the table or at a different table, whatever you want to do, I want you to find someone in the room and I want you to swap notes. Right now, I'm going to give you 3 minutes. Looking at the other person's notes, I want you to read them. If they missed something that you feel is important, I want you to handwrite it in onto their notes. So you are adding to your partner's notes. You've got about 3 minutes to get that done.
Roll, get up.
Got about 2 minutes. You need to add to them if they miss something. If they didn't miss nothing, you're good. You're just checking them. How does what? If it falls out of your mouth. No. Magic. It's totally magic, Raylan. All right, give them their notes back. Everybody take back your notes. You need your original notes. Now we're going to revisit them for the second time today. I want you to scan through your notes, highlight keywords, underline important things. Chunk your notes into sections and like ideas. Once you have that done, listen carefully. For every chunk is a heading, right? Every heading is a chunk. For every chunk, you need a Costas level 2 or level 3 question. What is not a level 2 or 3. What is a level 1 question. If you don't remember your Costas, they're in your journal. On, I think, the second page, we have Costas house. You're going to use the words in the house on the second or third floor to generate your questions. It says minimum of 3 questions per page. Ignore that. There's not a minimum or a maximum. I just want 1 question per chunk, okay? Here's your last piece today. You have one more thing of homework. You must write your summary over these C notes tonight. A summary, listen, answers your EQ. It answers your questions in the margin. It is complete sentences. It is correctly punctuated. It is correctly capitalized. Look at my paper. I don't feel that there is enough space in one summary box to do all of that. You have 2 choices. You can write it in one summary box, and if you go over, put an arrow and finish it on the back. Or you can do like I did. In your binders, you were supposed to have Post-it notes. I took 3 Post-it notes. I cut them shorter. I laid them over. I'll probably put a piece of tape across the top of this so it stays in place. I would start writing my summary here and then finish it underneath. So guess what? You've just made a foldable on your notes. Is your mind blown? No? Maybe a little? You can do the same thing for your questions. If you don't have enough room on your column for your questions, you can cut a Post-it in half and make a flap for those questions. Do what? If you can turn them in for Avid, this will make them a very good sample for Avid. Okay? So, before you leave, you're writing your questions. Your homework is to generate your summary. And what other homework do you have? The reading, right? When is that due? Friday. If you have not already, you should put that assignment on your calendar in your binder. So this Friday, write biology reading assignment due. Understood? Yes, ma'am. All right. Thank you, guys.